All right, good evening, everybody, and good afternoon or good morning, wherever you're watching from. Welcome to another Azure Sentinel live stream. And today we're going to talk about use cases. I think it's a very important subject and a lot of things are happening. Welcome, I'm Maarten Goet. I'm a Microsoft MVP on Azure, and I'm also a Microsoft Regional Director for Security. I have a professional hobby flying the real cloud, so I get to fly over the Western Europe Azure Data Center, and I'm a big community fan. But enough about me, because we have a special guest today. Hey, Koos.
Hello, everybody. My name is Koos, and I'm a security consultant at Wortel. And in my spare time, I'm also an amateur photographer. I'd like to yes, thank you. Like to slow cook some nice pieces of meat, mountain biking in the weekend, snowboarding, and I even spent quite some time on pinball machines, actually.
Love it. Those are all great hobbies for sure. Let's get underway with the subject. We're going to talk use cases. We have a lot of content to cover, and Koos will do some epic demos, so stay tuned for the next couple of minutes when he will pick up after me. But the question we get about use cases is very much about where to start. And the approach you could take is that of trying to model the threats. So define your security requirements, create an application diagram, look at how the application connects, which parts are involved, what things should we protect, and what are my crown jewels. And from the security requirements, of course, start to identify the threats. What actor groups, what types of threats could come after my environment, my company, and my application. And of course, then mitigate those threats and validate that those threats have been mitigated, and put that into a process so that it's a loop and something that returns, of course, over time. If you're asking yourself, like, where do I start with threat modeling? Microsoft has guidance from SDL. There's a link here, and I'll show it in a second, and we'll share those links, of course, after we've been off the air. But Microsoft has proper guidance on how to do threat modeling. They even have a threat modeling tool. It looks a bit like Visio, where you take the components of your applications, you map them, you put in the relationships, and it gives you at-a-glance information about your application and the threats, of course, that concern your application. And if you want to have a proper example, then on Azure Architecture GitHub repo, there's a threat model template that you can load into the threat modeling tool and that you can then use as an example for your environment. Now, the other thing when you're doing threat modeling is that you need some information on the types of threats, the types of actors, how to label them, how to classify them, how to understand the impact. Maybe you'd like to understand how these actor types work, what are the approaches they take, what are the pivot points. And so Mitre is a non-profit organization, and that non-profit organization provides you an open library on attack groups, attack methods, the mitigations, and many, many more things, very detailed, and very much something that the community can also contribute to. And I think one of the most known frameworks is where it's called attack. So there's an attack for enterprise, there's an attack for ICS, your industrial environment, there's an attack for instance, your cloud environment. And these things will guide you on your way as you start to threat model and try to map them in your environment. And here's an example from the attack for enterprise with the various phases in the cyber kill chain. So looking at reconnaissance, at initial access, execution, privilege escalation, and all sorts of things. The techniques, the tools, and the procedures that belong to those categories, and even the very specialized sub-techniques that give you information about a certain attack vector and how they work. And in my previous live stream episode, I talked about a specific T number, and we dove in and how that worked and how to use that in your environment. So Mitre is certainly a great source. And if you're wondering, can I map everything? I think there's a lot of things you can map from Mitre, all sorts of unknown situations where you're trying to categorize things like collecting, privilege escalation, initial access, and exfiltration.
I especially like the privilege escalation picture on that one. It's quite striking.
I think that was in Pelosi's office. Yeah. David, one of the Azure MVPs, did a great job on trying to map the Azure environment back into an attack matrix. This is the layout he made. A lot of useful information about which techniques, tools, and procedures adversaries could potentially use to gain access to your environment, but also do lateral movement and do, up until the fact that they're actually exfiltrating data. And this is something that's very helpful, and we'll share the link to David's blog afterwards so that you can actually see the information and use it for your environment. Now, when you're doing use cases, you'd like to understand, I think, which ones you've already covered. Like, what techniques have I already covered for my environment? Did I set up the detections? Did I already run the tests and potentially do both? And get a bit of understanding of the purple mode you're in, whether detections are there and tests are working. And one of the things to look at is the Attack Navigator. That's a tool that the Mitre organization provides you that lists out all of the cyber kill chain phases and the different techniques. And you can actually use a JSON overlay to color those T numbers and give at a glance information about certain coverage you already have. And our good friends Ruben Bouwman have actually already built a tool called Detect that you can find on this GitHub repo that actually automates a lot of the things and makes it easier. Another one I want to call out is from a great community guy called Chebby. I'm hoping I'm saying it right. Sorry, Chibeb. But he built a Sentinel-2 attack script that actually takes information from the Azure Sentinel repo, the official repo. It takes information from your Sentinel environment and potentially optional files from disk that the certain manual things you've set up, and then generates a JSON file and gives you information that you can run in Attack Navigate. And that's something actually that I want to show you. Now I've switched to my browser. Here's information from Microsoft, like we just showed, on threat modeling, the 5 major steps, and there's a section about the threat modeling tool, and you can download it from here. But there's also the threat model template, like we showed on GitHub. You can take this example and use it as a baseline for modeling your own application. Again, it looks very much like Visio, but very helpful to get this information. Going to Chiheb's repo, we find the Sentinel-2 attack script. This is a Python script, and let me load it up in Visual Studio Code. You see that it gets lists from both the local repository, from your Azure Sentinel instance, from the Azure Sentinel repo, and from files on disks, and then in the end generates a JSON file. So what I'll do is I've already cloned the repo here on disk. You see that the Sentinel-2 attack.py is here, and I can just run Sentinel-2 attack from Python. I've already cloned the public repo, so it skips that steps. And then it takes the techniques from Azure Sentinel, takes it from the GitHub repo, etc. And going back into Visual Studio Code, taking the JSON file and then formatting it nicely, we actually get a list of all of the T numbers, all of the techniques essentially, and tactics and procedures, the TTPs, that are now covered in my world. And when we go into Attack Navigator, and I'm using the hosted one, but you could fork or clone the repo and build your own or host your own. I can say open an existing layer. Here we go, upload from local, take that JSON file, and here we actually see all of the coverage that I have set up in my environment and all of the things that Azure Sentinel already does out of the box. So this is a great way, and also a great tip from Chiheb on building this. And you could then work from here with Ruben's work, Marcus' work with Detect, and really start mapping out your purple mode and getting information there. So this is something...
Oh, I'm sorry. I just wanted to add, Maarten, that the nice part about this is also that the techniques are added, right? So by default, only the tactics are added in Sentinel by Microsoft and not the techniques. But you can even use on your custom rules, you can use a prefix with a T number, and then the script will pick it up from there.
Yeah, beautiful. And so
Great
something
stuff.
like a naming convention will certainly help to get this going. But yeah, good tip, something to look at. There's a big debate, what I'm hearing though, in the community on whether, like, what the naming convention should be. So something to explore. If you have any preference on how we should name analytic rules, comment in the YouTube chat or on LinkedIn. We'd be happy to understand what you're doing. Cool. So looking at use cases, the next step, of course, is where you drag in and get in the data. Microsoft has a lot of connectors. At this point in time, just after Ignite last week, we already have 96 connectors and counting. Of course, there's a lot of Microsoft connectors, the ones you would expect, but there's also a lot of non-Microsoft connectors and certainly a lot more coming in the next few weeks. So stay tuned for those. But those are the prefabricated ones where you get workbooks, analytic rules, you get the information quite quickly with a few steps you can set them up. But there's also generic ones. If you have networking equipment, if you want to grab some OS events from DNS, maybe also something from other sources, there's a lot of generic ones. And the one I want to point out, and I know Koos is a big fan, is the Logstash one. So we can leverage Logstash as the Swiss Army knife or Swiss cyber knife to get stuff in, Koos.
Yeah, I like the Swiss cyber knife definition. Yeah, Logstash is amazing. I also wrote a few blogs about it in the past. And if you cannot ingest something with the default data connectors, you can probably make it work with Logstash. There's a lot of different plugins for there in which you can input logs into Logstash. And Microsoft also last year, I think it was last Ignite last year, they also announced the official Logstash output plugin from Microsoft. So now it's an officially supported solution where you can put the data from Logstash in a custom log table in a log analytics workspace.
Cool. Giving
so that's
and getting.
Nice stuff.
Yeah. Nice.
Yeah.
Pretty cool. Yeah, so this is the Swiss Army knife, and consider this if you are starting with Azure Sentinel and you'd like to work with some first use cases. The Azure Activity one, the Office 365 one, and the MS Defender one are actually free. So ingesting data will not cost you money and will help you to build some first use cases. And Azure Activity is already quite worthwhile, and we'll talk about that in a second. Now, use cases typically revolve around a certain scenario where you're trying to cover, let's say, a data exfiltration scenario where sometimes or typically you're trying to combine two or more alerts, maybe like an unusual login with some networking traffic, with something happening on the endpoint and something then happening, for instance, in your cloud environment on your CASB. Those things combined, of course, will give you a quite high confidence score on a certain scenario happening and something that your security operations center or your MDR can then follow up with. Certainly it's not limited to multiple alerts or multiple data sources, but the more data sources, the more confidence typically you get. And these are the things I guess we're trying to pursue. And then looking at examples, of course, like what can we do from here? Koos, could you tell us about how you would approach this? Like where do you start? How do you correlate alerts and such?
Yeah, well, I have some examples for you. So let me show my screen. So yeah, as you pointed out, one individual alert might already be a problem, but when you discover that multiple individuals appear to be related, then you might know there's a real threat, and then you must act on fast. And I can show you how to do that. So as we mentioned earlier, the data connectors are an important piece of Sentinel where you ingest the logs in from several different products. But what maybe not many people know is that even the Microsoft products, where you generally ingest only alerts, that you have some flexibility on that as well to work with. So if you look at the Microsoft products you showed earlier, for example, Azure Defender, and you scroll all the way down to the right, you see there's a button there, and they recommend you to push on that. And what it actually does, it will create an analytics rule for you. And as you can see here, the rule type is a different type. So it's not a scheduled rule where you put in custom KQL. It's a Microsoft security type rule, and it will automatically trigger an incident for every alert that is coming from those respective products. If we open up the analytics rule, we have some flexibility here. So in this case, you see an Azure Defender example. And this is actually a screenshot from one of our customers where they wanted to exclude all the notification alerts. Some of those products generate a lot of notification alerts, and by default, they will be set into an incident as well. So as you can see here, high, medium, and low are the only severities that will trigger an incident. And then you can even include certain events. So in this case, malware was prevented or malware was detected, might be alerts that you want to see as an incident, even though it is a notification alert. So this makes it possible to even create exceptions on top of your exclusions, if you will. And the bottom, you see that detected, obfuscated command line was excluded. And in this particular case, we wanted to do that because we had an issue with Ansible processes deploying playbooks to virtual machines. What not everybody might know is when you exclude it here, it is still in the workspace because the data connector is still ingesting all the alerts from the product. So by excluding in the analytics rule from Microsoft, we can build our own code on it. And in this case, we might, for example, look for obfuscated command line executions from Azure Defender, but exclude the ones who are initiated by that particular Ansible process, for example. So that is an example of how you could integrate your own custom rules with existing Microsoft products. But I have some other interesting issue I'd like to discuss, and this is also a real-world example. So we have a problem to solve. Security analysts mention that they are flooded with incidents caused by 2 specific alerts. After triaging, they conclude that up until now, these were always false positives, and those incidents were atypical travel alerts and unfamiliar sign-in properties. Those typical alerts we see a lot popping up at environments at our customers. And if we take a closer look, the atypical travel is fed by the Azure AD Identity Protection product and the unfamiliar sign-in properties as well. And they look kind of similar, but they are a little bit different. But they will trigger based on certain behavior of users and also based on the history of where or how that user typically logs in. But what we saw in this particular case, and let us grab in another alert, which is quite similar to this one, the impossible travel as well, which comes from Cloud App Security. And that will, as people probably know, will trigger when you have multiple activities from users in geographic locations too far away from each other, where it would not be possible to travel that distance in the time between. Those are very similar alerts, and we saw these alerts popping up at a customer where they used a lot of VPN appliances. So the security team saw that a lot of connect and disconnect sessions from the VPN triggered one or multiple of these alerts. So we wanted to correlate the VPN logs with these, travel alerts, if you will, and see what are the actual alerts we need to investigate. So we want to exclude all the VPN events from it. And to start with that, I have an example prepared here. On the left, you see a table in which I combined all of the travel alerts. So the 3 different alerts I mentioned earlier. And I will dig into the KQL later in the demo to show you how you could construct a table like this. So we're already correlating between different Microsoft products in one overview. And on the right, you see a list of VPN logs coming from a Junos Pulse appliance. And obviously, this is all synthetic data, but just I wanted to show you how you would correlate two different tables. With KQL, you can do a join on those tables, but more on that later. So if you see here on the left, we got an impossible travel activity alert from Peter. And about 3 minutes earlier, he connected a VPN session. So they are probably related. And the same goes for Grace. Susan triggered an alert on the left, but apparently there was no VPN log for there. So that is something we need to investigate. Maria as well. They might look similar, but there's almost 12 hours of time difference between those two events. And John is also not in the VPN logs, but Dan is. And Dan was earlier that day as well. So we see with our own eyes, it's quite easy to align these events. But when you have large logs, it might be difficult to do that. And I'm going to show you how you would do that with KQL in the demo later. So in this case, in KQL, you will need a join statement. And in this particular case, one with an outer kind. And an outer join will join both tables based on a certain column. But if something on the table on the left does not exist in the table on the right, it will still keep that line. Because if the alert on the left is not on the right, then we want to keep it, right? And the column stays empty in this case when we do an outer join. So in this case, if we would outer join these two tables, the Susan line and will remain empty. The columns would remain empty. The Maria line will be matched because Maria, the UID matches up, although the time is completely different. The John line will remain left, but then when we enter the first event of Dan, we run into an issue because the join will match all of the UIDs on both tables, and it sees two Dan events on the right, so it will duplicate the line on the left to match both of the results on the right, and it will do that again with the last line. So this is what you will end up with when you do the outer join. And then obviously we have to fix some stuff. We have some duplicates, and we also need to fix the time difference because we obviously cannot match those two tables purely on their timestamp because they will obviously never be exactly the same from both of those appliance and the security products. So yeah, let me show you how you would go about to such query. In this case, I have prepared some synthetic data, the same data I used for the slides. I think it's easier to demonstrate. And what I did here was actually use the watch list functionality of Sentinel to make up some synthetic data. So I just created a couple of comma-separated files. I uploaded them into a watch list. And as you can see here with a let statement, I'm pulling all the alert logs from a watch list. And when I uncomment this line, you will see that we have the table here, which I showed earlier on the left in the slide. The same goes for the Junos Pulse logs. I will obviously show you later how to combine all those multiple logs, but I just want to focus first on the joining part. So the Junos logs show the VPN logs, also showed you earlier. And now we want to do a join on those two tables, right? And that's what you can see here. So we perform the alert logs command where we retrieve the data from the watch list. And then we do a join with a count left outer. So we want the left table to be in the lead here. And we join it with the Junos logs table on the UID column. So the UID column is the one it should look for matches. As you can see here, let me sort by alert time. As you can see here, this is exactly as the screenshot showed in the PowerShell. So we see empty columns empty values in columns where the right table, there was no matched found on the right table. So now we have the challenge to take out those duplicates. What you can actually do is, in this case, using a summarize command with the argmax command, where you pull out only the latest alert date time and the latest UNOS date time. Those are the names of the columns here from both of those tables. And when you do that, the duplicates like Dan were removed, like we saw earlier, because we had those duplicates because they matched up multiple times. And then the last challenge we have is to sort out the time difference, because as you can see here, the Maria line, for example, still has that 12-hour time difference. So it's safe to say that you want to investigate on this one. To demonstrate it easier, let me add a column, time delta, where I use a command called ABS to calculate the time difference between two columns in minutes. And we can see here that the time delta shows that this line has a very large delta, and these match up quite nicely. So what we can do here is exclude the results where the ABS results in more than 5 minutes, or where the values of the columns are empty, because remember, those were the original alerts which didn't match up with the VPN alerts. And then you end up with a list with 3 events, which you actually need to investigate on instead of the original 7 we had in the original example. So this is to demonstrate how to do a particular join kind with VPN logs. And again, these logs were now constructed from a comma-separated file, but in the real world, they would obviously be ingested with syslog or maybe through that logstash solution. How did I construct the list with all the alerts in one table? So for this example, I can show you we have ingested some synthetic logs as well, but these are actually logs coming from the Microsoft product. So in this case, the unfamiliar sign-in properties would look something like this. So we have a lot of columns we probably might not need after all. And the same goes, for example, for the impossible travel activity. But the thing is, when you need to construct one table where you want to join it later, you have to make sure that all the information in the tables, like the UID in this case, and the timestamp, maybe IP addresses, everything you add is the same, because otherwise you'll get a big mess. So especially with the impossible travel activity, it was a bit difficult. We had to retrieve the user ID from the description field. So let me show you. I'll make this a little bit smaller. So in here we have 3 let statements, one for the familiar sign-in, unfamiliar sign-in properties. We're going to dig into the unfamiliar sign-in properties. We're doing some stuff with retrieving the IP address, location, and the UID. And in this case, we decided to split it at the domain name. So after the @ sign, it gets removed, because the UNOS VPN logs were just showing the UPN without the domain name. So that's why we're trying to make the data as easier to compare. The same we do for the atypical travel and for the impossible travel activity, as I showed before. We had to do some parsing on the description to retrieve that username and retrieve some other stuff from there. But eventually, we'll end up with a table. We call it travel alerts. Where is it? There it is. Sorry, I'm skipping a step. So the unfamiliar sign-in properties will now show all of the unfamiliar sign-in properties, where it will only project the columns we need. That is defined in the let statement. But now we need to add all of these, like also the atypical travel, in the same table, right? Instead of doing a join, we would be using a union in this case. So in this case, I'm thinking of a new name, in this case, travel alerts, where we pull up the results from the unfamiliar sign-in properties and then union those results with both the atypical travel and the impossible travel activities. And if I run the travel alerts command, then we'll see that we get the result as we showed earlier, where all of the different alert types are in one massive table, because this was a large data set, I think 7 days worth of data, but eventually you'll see those impossible travel alerts as well. But they're in there. So then we have one table where all the travel alerts are in. And then from there, it's actually the same as I showed before. So there we can say, okay, so the UNOS pulse logs should be ingested as well. We can do that same argmax to remove the duplicates and calculate the date-time difference. And then we get the results. Let me see what, oh yes, I can do 2 queries at once. And then the results is the same conclusion as we saw before in the smaller tables. So this is a practical use case we used with several customers, and well, we might be able to share the KQL we showed now after the live stream, wouldn't we, Maarten?
Absolutely, yeah. We'll share this, I guess, as gist on GitHub if you want to. Yeah.
Yeah, sounds good.
Sounds good to me.
So let's continue on with a few other examples.
Yeah, I think there's another great example on other use cases, right?
Yes, that's true. I have a few other examples. A few of these leverage the Azure Activity Data Connector you mentioned earlier. It's a free data connector and already gives you quite some interesting insights if you know where to look for. And I want to provide a few examples. In this case, one of the use cases we have is the rare subscription level operations in Azure. So you might imagine that activities like, in this example, creating and updating a snapshot might be for backup purposes, but can also be abused by an adversary to extract sensitive information. But you can also use it to within your KQL to maybe look for certain deployments, maybe the creation of certain virtual machines or certain resources that you not regularly use. The next one, rare application consent. And in this case, we used actually 2 KQL queries in one analytics rule. First, we look at a longer time period to determine what is regular. So who are people who normally would consent to an application, and from what IP do they do that, and how often do they do that? And then we have our baseline, so what is regular? And then next we can compare the results of that with a shorter, more recent time frame to see if it exceeds the expected results from before. And again, it will not always mean that there is something wrong, but you can detect the anomalies in that way. Also with the suspicious granting of permissions on an account, looking for things like global admins manually assigning users to resource groups, or in any way assigning users to resource groups where you might have the policy in place to do that through user groups instead, or look for IP addresses like here in this example. When regular permission changes are done, from which IP addresses are those done? You probably get a list of all your known office locations and maybe home IP addresses from certain administrators. And then you can match those IP addresses back with recent permission changes and get an alert when a new IP address pops up, because that might be an indicator of an issue. Another example I wanted to show you is guest users. When we see more and more, especially larger organizations, using a very large number of guest accounts in their Azure AD. And sometimes it's also difficult to keep track of all the authorizations going on, especially in large companies where people get automatically added to groups and such. But I think that in most cases, guests would not be granting permissions to other users or groups. So this was one of the use cases we created in the past, where we looked at the caller ID for those permission change actions. And we looked at the domain, and from the domain you can obviously detect if it's a guest user or it's an actual company employee, and then alert on that, for example. And lastly, is one I want to dig in a little bit deeper. When a global administrator elevated access to the root management group. And this one actually we found was thought of by Sami Lampu. I hope, Sami, that I'm not butchering your name. Sami is a security consultant from Finland, and he wrote a few awesome blogs about this issue, because it's not that easy to detect with the existing solutions in place. And he found a solution for that, and I'm glad he shared his knowledge in his blog posts so that we could benefit from that as well. And I want to show you what the actual issue is here. When you work with management groups, you always have a default root management group in the top, where all your subscriptions are linked to, and you might have some additional child management groups and maybe a whole structure with childs and parents, and your subscriptions are in there, and the management group will automatically make sure that all of the RBAC permissions are inherited to those child objects. When you lose access to maybe an account who has root level access or who created the initial management groups, you might want to siege, if you will, those permissions and get access to that root level management group. And the way you do that is you log in with a global administrator. You go into the Active Directory properties you see here on the left. You click on the Yes button and you click on Save, and that way the Azure platform will automatically authorize the global administrator as an owner of the root management group. And you will automatically also gain access to all of these subscriptions and management groups below that. And there's a reason to separate the global admin or directory roles with Azure roles in the first place. But this can be a solution to work around that, for maybe create a new break glass account or something like that. But it is not something you would like to do quite often. And if it does, you want it to show up in the audit trail, right? But the funny thing is, even if you connect your Azure activity to Sentinel, you get a lot of audit messages from the Azure platform, as you can see here an example. But they're always scoped on a subscription level. You don't see any management group level activities audited by default. And when you look closely, you see a lot of Microsoft authorization actions as an operation name. But those are more delete, write, and those kind of actions. So what Sami discovered is that when you link up Cloud App Security with the Azure activity, those elevated actions do show up in your logs. So as you can see here, the elevate access, which is also a Microsoft authorization operation name, does show up in the Cloud App Security portal after this was connected. But we want to create an analytics rule on this from Sentinel perspective. So how do we do that? Well, we have probably already also linked Cloud App Security with Sentinel as well. But the problem is that by default, only the discovery and the alerts are ingested by Sentinel, not the activities, which we need in this case, where this audit log is saved to. So I think in the near future, there will be more possibilities to solve this, because Microsoft is already working on a 365 security data connector from Sentinel, where you can ingest all the raw logs from, let's say, Defender for Endpoint. That is still in preview, but it is available now. And the Cloud App Security and other products are already listed in that UI with a coming soon remark. So I think it will be a possibility in the future, but for now we don't have that. So how we can solve this is with a logic app. And within the logic app, we can do an API call to the Cloud App Security platform and retrieve those activities and put them in the log analytics workspace from Sentinel as a custom log. And that way can write KQL again in Sentinel and create a detection rule for those events. And it will also trigger an alert if somebody performs this action. So let me show you quickly. So as I mentioned, the logic app we defined for this, and I do hope it's going to load now. I'm not sure why it wanted to reload this. Also, always makes me a bit scary when doing demos.
It's always with live demos.
So in this case,
right?
Sorry, Maarten?
No, I said it's always with live demos. You're praying that that things go right.
Yeah, I forgot to praise the demo gods beforehand, so it's always a risk.
Yeah.
So in this case, the logic app is using a recurrence, a regular schedule. For example, pull every hour those activities from Cloud Obscurity. This is obviously the ugly way. In production, we would not do this, but here is an API token we generated from Cloud Obscurity. Ideally, you would want to use an Azure Key Vault or maybe deploy this logic app with a secret variable from your pipeline. And that way it will not end up in plain text here in the function, in the logic app. And there we see the API call to the Cloud Obscurity platform. We need to parse it to JSON. Sami based the schema on another blog post from Microsoft, which you can read on the on his post as well. And then for each of the activity coming from the platform, we want to send that data into the log analytics workspace. And in this case, we're using the MCAS activity log custom log table. And then eventually the data will show up in Azure. We already created an analytic rule for that before this session. And we'll end up with a few incidents because I triggered this a couple of times. So as you can see here, the global administrator elevated access to the root management group, and we can go ahead and investigate the incident, I'm sorry. And from here, we can look at what other incidents might have been caused by this admin. Oh, I'm sorry, I clicked on the wrong button.
But this is
so
beautiful.
From here, you can do your investigation and go to related alerts, for example. And we see only the same other alerts in this case because this is a demo environment and we don't have a lot of real world data in there, but you get the picture, I hope.
Yeah, this is beautiful. This is something where you're using a lot of information from all of the Microsoft tech that you have in your environment and combining them into new use cases that are relevant for your situation. And great work also by Sami.
Let me show. Yeah, it's great that he shared this knowledge because it's still quite weird to me why this wasn't part of the default Azure Activity Data Connector. But as I mentioned before, wanted to show you quickly that the new 365 data connector, which they released a couple of months ago, we have an extra button already here in place for Cloud Obscurity. So in here, you can ingest the raw logs from Defender for Endpoint, for example, and Cloud Obscurity is already listed here with a coming soon remark. So I am sure that this will solve the need for the logic app in the future. But for now, I think it's worth it because it's an important activity you want to have logged somewhere and want to investigate if it happens.
Yeah, wonderful. This is really a great example. And thanks again to Sami and all of the folks that are contributing use cases because together we're becoming more secure by sharing this information, right?
Yeah, that's true. So now you're working with all of these use cases and you're creating all those nice KQL queries and making some exceptions on existing rules. But how are you going to make sure that that all those changes are logged somewhere? And how you maybe, especially when larger environments, how you're going to work together on this? You might consider some DevOps way of working for your security product as well. So with converting your detections as code, you can put your detections in a centralized Git repository, for example. And it makes it much easier to work together, especially when larger customers, where they have multiple workspaces across the globe. It's much easier to deploy from one centralized environment. You have obviously all the benefits of version control. When you did an exception 6 months ago, you can log why you added that exception so that you remember it when you make another change from your code the next time. You can also leverage automatic deployments. Think about maybe deploying your DNS-based use cases automatically once the DNS events table gets filled in the workspace, so that you can automatically deploy use cases to other workspaces. Also, this is very powerful when you're, well, like I mentioned, working with multiple workspaces, but also if you're a Microsoft partner, maybe like us, who wants to be able to deploy detections and even workbooks to their customers. So here's an example of how the Microsoft security detection rule from Azure Defender, which I showed earlier with a couple of those exceptions, would look like as code. And you can extract this analytics rule from the Sentinel workspace by leveraging the APIs, the Sentinel APIs, or of course by using our very own AZ Sentinel PowerShell module, which we're still grateful for all the work that Pujan Kabassi put into that, and still does, and also the rest of the community contributes to that PowerShell module. So it makes so you can connect to a workspace and retrieve it as a JSON from there, and then you can store it in and redeploy it also with the same PowerShell module, obviously. And here's an example of a scheduled query rule I mentioned before, where we showed the more complex query, as you can see, as part of the JSON as well, and also the query frequency and other incident-specific settings are in there. So I already mentioned that it would also be interesting for Microsoft partners or other companies who'd like to deploy content to their customers. And now with Azure Lighthouse, you can even extend these deployments to other tenants as well. So in this example, you can see here we have a couple of tenants, customer tenants, and they each run a Sentinel workspace. And as this example, we take our own tenant as a partner. And with Azure Lighthouse, we are able to deploy detection rules from our own Sentinel workspace into the workspace of the customer. And how that works is that the rule stays in the workspace of the partner, in this case, Wortel. And within the KQL code, we refer to another workspace. And through the power of Azure Lighthouse, the whole authentication part is done for you, and you can just query another workspace as it was a workspace in your own tenant. And this makes it gives you the opportunity to create incidents, and it, by the way, might also be maybe a slightly downside to this is that the incident will also be created in the workspace where the rule exists. So you have to make sure that if you're going to do this for your partners, that you're also responsible for incident response for them. But the great thing about this is that you can protect your intellectual property this way. So the customer cannot see the actual rules in their workspace, so they don't know what KQL logic is behind that, and you can manage that for them. And obviously, if you have multiple customers, you want to define multiple separate rules for that, because they will all create their own incidents separately. So you want to make, we've spoken about naming conventions earlier. Then you have to think about a way of which the customer is also part of that naming convention, because it will also reflect back on the incidents it will create. And not only for, it might be handy, but books. So you can create maybe a centralized dashboard where you can see the health and all of the metrics and statistics of alerts and incidents and how analytics rules are behaving at your customers. And it works the same way with an analytics rule. Within a workbook, you can provide KQL query and you refer to that other workspace the same way as you do with an analytics rule. And you can obviously also deploy workbooks to customer tenants as well, if you would like to provide them some way of maybe their own dashboard where they can see their own health of their own environment. So it's good that Azure Lighthouse provides you the ability to keep the rule logic to yourself and help out customers this way who might not be not have the skills or the time to invest in creating their own use cases themselves. Back to you,
Very
Maarten.
cool. Yeah, very cool. This is a good example of detections as code, something that maybe not a lot of people are doing yet. But like you said, through the power of the Azure Sentinel PowerShell module, Azure DevOps, and a bit of YAML, JSON, they should be able to get this done, right?
Yeah, it's great.
Cool.
And especially when you have a use case library like we have. I'm working with security engineers and analysts on our side as well, and we can just refer to we have specific codes made up for every analytics rule. So if we say, well, can you take a look at WS 102, for example, and we can work together on that in that Git repository. And when the change is committed through a pull request, it automatically is deployed to all of our customers. So all customers benefit from that afterwards.
We're all getting more safe together. Beautiful. Yeah, love it.
I hope so. Yeah.
Yeah. Well, talking about staying safe, a lot of things are happening in the past few days. I think pretty much everybody in our work area is working on those Exchange 0 days, the Hafnium labeled attack that happened in the past few days. And what you see is that there's a lot of guidance from Microsoft on what the attack is about, how to mitigate, providing emergency patching and more. Microsoft CSS also published the Exchange known good hashes. And they also published a PowerShell script to analyze your Exchange server. But what if you want to use them in use cases? Well, that's a good question. My colleague Jeroen actually created a script this afternoon to take those hashes, put them as IOCs into Azure Sentinel, and then work your way through threat intelligence and those custom IOCs for use in your use cases. So you can take that PowerShell script, it will take the public repository and push them into your Azure Sentinel instance, and then through KQL queries like these, using the threat intelligence indicator table, you can actually use that indicator in your own use cases. So I think that that is a great step forward. Now, I'm seeing a lot of activity here on YouTube, but we also got 2 questions ahead of time from Wim on LinkedIn. The first question was, how does Azure Sentinel detect and respond to a ransomware attack? And second, how to detect suspicious activity on an industrial network using Defender and CyberX. So let's take those questions. A ransomware attack. How would Azure Sentinel know that there's something happening from an adversary?
Yeah. Well, Azure Sentinel itself wouldn't know anything about ransomware, actually, fun fact, but it will rely on input coming from other security products. So across the whole chain of how a ransomware attack could penetrate your organization, Defender for Office 365 might already be able to pull it from an email coming in. Cloud App Security could prevent you from clicking on a link in that email, and Defender for Endpoint can remediate the ransomware attack coming from maybe a USB drive or some other locally running process. You must see Sentinel more as the orchestrator of it all, orchestrating all of the alerts coming from the different products. And obviously, when we saw the investigation shortly in my earlier demo, Sentinel will correlate the events across all of those different products. So when you do an investigation, you can see, okay, this process started at that machine and then pivoted to that machine, or somebody moved laterally, or it came in from an email like so from this product.
Yeah, great. So we're using all of the other tech to really combine signals in Azure Sentinel. And the second
Yeah.
question is how to detect suspicious activity in an industrial network. I think it's along the same lines, right? We're really relying on Defender for IoT, previously called CyberX, to find those signals in ICS and SCADA networks.
Yeah.
Beautiful. Well, there's live questions on YouTube, but if you're on YouTube, go hit subscribe. Make sure that you are here for the
Don't
next...
forget to click that notification bell.
Thank you for that, Koos.
We're getting real YouTubers, Maarten.
Oh, this is all professional. Way too much, way too much. You do get a suggestion from Ronald Prasad, I'm not sure if I'm pronouncing it right, who said earlier in your demo that MCAS Alerts has a column called Compromised Entity, so you didn't need to parse the username from the message field, so he suggests using that field. We get some compliments from Tristan and others on the great session, but there is a question from Pierre saying, what are your customers saying about the costs for Azure Sentinel, and approximately how much data are they ingesting into Azure Sentinel? I think it's a topic we hear quite a bit from customers, like, what is Azure Sentinel going to cost me?
Yeah, it's also the most difficult question to ask in a proof of concept when you start with Sentinel. Yeah. One of the advice I always give my customers is not to treat Sentinel as your on-premises SIEM. So please do not ingest every log you have coming from whatever device you have and just put it in Sentinel, and then with the logic, we'll think about the logic later, because the whole cost model is different, obviously, because you pay for your ingest data. Yeah. But you see, with products like Defender for Endpoints running on virtual machines, there might not be the need anymore to ingest all of the signals and logs coming from every virtual machine. There might be some exceptions, like domain controllers or other specific high priority machines, but that's always a difficult thing. With my customers, I try to keep the logs as low as possible, So if they have a new project and they want a new product and they want to ingest all of the logs somewhere to just keep it for governance or policy reasons, I advise them to use a separate workspace for that and only ingest maybe certain events into Sentinel to create analytics rules on, because that's the only way it's making sense to ingest the data there.
Well, and that's a key point. I was debating with Olaf Hartong the other day that he was still ingesting a lot of Sysmon data to complement the data we get from other products. And while we still rely quite fairly on the Microsoft Defender suite with all of the raw data that stays in Defender, but the signals you get into Azure Sentinel, and then actually the storage you need in Sentinel is quite low. So, of course, the consulting answer would be it depends. It depends on scenarios, environment, and much more. The interesting part, of course, from a pricing standpoint, is that you can pre-commit certain storage, and then, of course, the price per gigabyte, per terabyte goes down. But to my field experience is that we're seeing good numbers, because if you're relying on EDR and XDR solutions to do the heavy lifting, then Azure Sentinel itself shouldn't be a big data lake all it by itself.
Yeah, we normally take a look at it per case. So if you have virtual machine logs, let's first check if you can eliminate a few of those, maybe by, like I mentioned, Defender for implementing Defender for Endpoint. If you have domain controllers, you can also maybe decide to buy Defender for identity. So to protect those security logs from there and ingest the alerts back into Sentinel. But if a customer has an existing SIEM, it's useful to calculate the approximation of logs they're going to ingest. But I would never use a lift and shift migration on a SIEM like this.
No, same goes for data center migrations.
That might not be the answer Microsoft would give you, by the way. But I'm not sure on that.
We're not Microsoft, so this is our answer.
No.
We're getting a lot of questions if this is recorded and if it will be published. It's all recorded. It will be published. We publish our scripts. So we'll send out the links. Follow us on Twitter and LinkedIn, and you'll get all of that great stuff. We are at time now, Koos, so let me wrap it up.
Yeah.
If you need any help, if you think this is something you want some assistance from, Wortel has a use case library that we built over time with our managed detection and response colleagues. And of course, we're running a 24/7 operations center, an MDR, that can help you stay safe when you are sleeping, all based on cloud native, Azure Sentinel, Microsoft Defender, and the other goodness. If you want to get more information about Azure Sentinel, there's an ebook. Funny enough, I do have the real book. So this is printed.
Printed ebook.
A printed ebook. That's like, wow, inception. But happy to send over a real copy if you want one. But go to wortel.nl and there's the ebook digitally. If you want to stay up to date, I have a blog on maartengoet.org. I know Koos is blogging on Medium, so go find him on medium.com. And securityinsiders.io is actually where you'll find a lot of podcast episodes where I spoke to various Microsoft folks, various folks from the community, and dig a bit deeper about the things they're doing and that they're seeing. Now, again, if you want to stay up to date for the next one, hit the subscribe button, stay up to date, ring the bell, as Koos would say. And we'll
smash that notification bell.
Smash that notification, and you'll be here next. We'll be doing one in the first week of April, so if you want to know when and where, go to my YouTube channel. Koos, I want to thank you so much for doing an epic demo. I loved what you showed.
You're welcome. Until the next time.
Until the next time, everybody.
Bye-bye.